So, hello everyone, welcome back to the channel. In today's video, we'll look at some problems on logarithms which have already come up in both JEE Mains and JEE Advanced. So, let's start with the first problem, which says 3 to the power x is 4 to the power x minus 1. So, we'll write this term first. Write the question is 4 to the power x minus 1. Now, we'll take log on both the sides to make our work easier. So, log 3 to the power x is equal to log 4 to the power x minus 1. Now using the property of logs, we can write x into log 3 is equal to x minus 1 into log 4. Now we can write this as x log 3 is x log 4 minus log 4. So log 4 is x into log 4 minus log 3. We just transpose this these sides, this here, and yeah. Now log 4 by log 4 minus log 3 is x. Now we can take log 4 as common on both the numerator and denominator. So log 4 by log 4 multiplied by 1 minus log 3 by log 4. This gets cancelled out. So x is 1 by 1 minus. Now we can see that this is a form of base changing theorem which we learned. It's a converse. Yes. So we can write this as log 3 base 4. So our x is 1 by 1 minus log 3 base 4, and that is the value of x which satisfies this question. Now let us look at the second problem of JEE. Now this is the second problem. So in this, let's write this first as log 2 base 7 is k. Now we need to find the value of this log 28 base 49. Now what we can see is that in the base we have 49. That means we have to make this 49 and this as 28. Now for this we have a technique. First of all, we need to change its base to 49. So that rest work we can do it later. Now to make its base 49, we need to square this. So for that do we'll do the reciprocal. We can write this thing as 1 by log 7 base 2 using the property of log which I told you in the previous video. Now we can multiply by half on both the sides. So half into 1 by log 7 base 2 is equals to k by 2, right? Now 1 by log 7 square base 2 is k by 2. Now we can write this as log 2 base 49 back, yes, is equals to k by 2. Now we need to multiply by 14. So what we can do is log 2 base 49 plus log 14 base 49. On both the sides we can write this is equals to k by 2 plus log 14 base 49. And what is this? Log 14 into 2 base 49 using the property of logs again. So log 28 base 49 is k by 2 plus 14 is 7 into 2. So we can write this as log 7 base 49 plus log 2 base 49. The 7 base 49 is log 28 base 49 is k by 2 minus half, sorry, plus half, since 7 base 49 is half because root 49 is 7, right? Plus log 2 base 49. And if we see back, we are given log 2 base 7 as k. Okay, so log 2 base 49 is, let's rewrite this here in the on the side. So log 2 base 49 can be written as 1 by log 7 square base 2 back, right? And this is nothing but half of log 2 base 7, and log 2 base 7 is given as k. So This can be written as k by 2. Now log 28 base 49 is equals to k by 2 plus half plus k by 2. So this becomes 2k plus 1 by 2. This is how we write this log 28 base 49. Okay, so that was such an easy problem, as we can see. Now let's look at the third problem of JEE. Now this is the next problem, which seems to be a bit difficult, but it's very easy. It's just one property throughout the question, which we'll see now. So we are given log 9 base 2 square to the power 1 by log 9 base 2 base 2 into root 7 1 by log 7 base 4. Okay, so we can write log 9 base 2 to the power 2 by log 9 base 2 whole base 2, right? And into root 7 can be written as 7 to the power 1 by 2 into 1 by log 7 base 4, right? So let's write further. Yeah, so log 9 base 2 to the power, now using the base changing theorem, we can write 2 by, no sorry, 2 multiplied by log 2 to the base log 9 base 2, right? We just use the base changing theorem that log b base a is 1 by log a base b. So just use simple theorem, and the same thing we can write 1, yeah, so log 4 base 7 as the power. We just simplify this power to the, and by 2. Now half can be written as root 4 to the power half. So let's go further. Log 9 base 2 in raised to the power log 2 square, since n log b base a is always log b to the power n base a, yeah, to the, and base 9 log 9 base 2 in multiplied by 7 to the power log 2 base 7, since we can write this as log root 4 base 7, since half is the coefficient of this log, and we just took this half as the power of the log 4, yeah. So now here we can use one theorem which I already told you in the previous video, but I can state it once again, that if we have a to the power log b to the base a, we'll write this as b. This is the main theorem which will make our question very easy. So in this we can see that log 9 base 2 is a, and it is same in this form, right? You can see it, you can visualize this, that this is a and this is a. So it is just 2 square into, and here again 2, right? Now 4 into 2 is nothing but 8, and 8 is the answer for this problem. So that's how we solve this problem. It was very easy. It's just simple properties which we did like saw in the previous video. Let's look at the next question. Now this is the next problem. This is again very easy. You can solve it after just seeing it. Now we have a as log 2 base 10 and b as log 3 base 10, and we need to write log 60. Now from this number you will get the idea that's just 2 into 30, or you can write 3 into 20. These are two possible forms which we can see from these two values, a and b, yeah. Now we have to take one of these in consideration. So let's take 2 into 30. Both will work though, whatever you want. 2 into 30. Now we already have 2 here, like in on the A. So we need to just add 10 to the 10, like we need to make it 30, this number. So we can write b is log 3 base 10. Now we can add, suppose log, we need to multiply it by 10. So for that we can add log 10 base 10. This is just 1. Yes, you can see it. So we'll add b, we'll write it as b plus 1 is log 3 base 10 plus log 10 base 10. Alright, so b plus 1 is log 3 into 10 base 10. So b plus 1 is log 30 base 10. Now to make it 60, what we'll do is we'll add a and a, this equation, let's name it 2, and the first equation of a, which we named at 1. Now if we do 1 plus 2, so a plus b plus 1 is log 2 base 10 plus log 30 base 10. Now a plus b plus 1 is log 2 into 30 base 10, and that is log 60, because 10 is the default base which we take in logs. You may know that. So a plus b plus 1 is the form if we express log 60 in terms of a and b. That's how we solve this problem. Let's look at the next question. Now this is the fifth problem. This is a very fun problem which you may like its solution. So we have this expression plus log 2 base root 2. Now we can write a as log base 2 log base 2 log 256 base 4 plus log 2 base root 2. Now 256 is 4 base 4, 4 to the power 4. So log 4 to the power 4 base 4 is 4, and rest are log 2 and log 2, plus 2 is root 2 square, yes, to the base root 2. Now we can write a as log base 2 log base 2 4, no, 4 base 2 plus 2, since we just take this 2 and this is just 1. And now log 4 base 2 is 2, because 4 is 2 square. So log 2 base 2 plus 2, and log 2 base 2 is 1. So a will be 1 plus 2, a becomes 3. So this was a very easy JEE problem as per its level. So a is equal to 3. Let's see the next. Now let's look at the next problem, which states 1 by log pi base 3 plus 1 by log pi base 4 is greater than x. So what can be the possible values of x? So for this, we can write 1 by log pi base 3 plus 1 by log pi base 4 should be greater than x. So what can be the possible values of x? Now we have to take the same base on both the sides to simplify this expression. So we using the base chain theorem again, log 3 base pi plus log 4 base pi should be greater than x. Now it can be written as log 3 into 4 base pi. So log 12 base pi is this expression. Now this means that pi to the power x is 12. Now pi's value is 3.14. Now if we square it, it's nearby 9 maybe, yeah. And if we cube it, then it's around 27. Now we need it, so it will be approximately around 2 point something, yes. So then x can be, um, so the possible values of x is that it should be less than 2.2.5, or x should be less than 2. this is the good value. If x is less than 2, then this is greater, right? That's how we approximate the value in this situation. And rest depends on if there are MCQs, then you can just tick some option nearby 2, because it's like you won't ever get very near values since it's just based on its approximation. But yes, if you have a calculator with you, then you can check the approximate value of what it is coming. Okay, now let's look at the next question. Now this is again a very good problem, I would say. So in this we have gotten infinite series, and we call it as a GP. Yeah, so we don't know what GP is, so I'll just tell you the formula for the infinite series of GPs. What is the formula for that? So we have the question as 0.16 to the power log 1 by 3 plus 1 by 3 square plus 1 by 3 cube plus till infinity to the base 2.5. Now to solve this GP series, we need to find, we have a formula which will just apply in this. So for in GP till infinity, GP for infinite series, the formula is A by 1 minus R. And R here is the change in the power, by what power is changing, and then C. So it is just the ratio of the two terms. Like in this case, we have 1 by 3 plus 1 by 3 square plus 1 by 3 cube. So let's take it as A, and this is A1. So A1 by A becomes your R. So in this case, our R is 1 by 3. A is the first term, which is 1 by 3. So so solution for this can be 1 by 3 by 1 minus 1 by 3, which is um, yeah, 2 by 3. So it's 1 by 2. So it's just 1 by 2. So we have simplified the series. The main part of the question was to just simplify the series. So 0.16 log 1 by 2 base 2.5. Now 2.5, now we'll remove the decimals because we need to make our question very easy and simple. Yeah. So 16 by 100 to the power log 1 by 2 to the base 2.5. Now 2.5 can be written as 25 by 10. Yeah. And now after cutting it off, we can write it as 4 by 25, and this as 5 by 2. Now we can write 4 by 25 as 2 by 5 whole square into log 2 to the power minus 1 base 5. Now taking this coefficient, we can take it here in the front of log as a coefficient. So 2 to the power raised to minus 2 into log 2 base 5 by 2. Now to make this 5 by 2, we can write this as 5 by 2 to the power minus 1 into minus 2, yeah, into log 2 base 5 by 2. Now this is okay. So we can write this as 5 by 2 to the power 2 into log 2 base 5 by 2. Now we can take this 2 here. So 5 by 2 to the power log 4 base 5 by 2. Now using that theorem, we can simply write this as 4. And 4 is the answer for the simplification of this question. So the value is 4. So that's how we solve this easy problem, which just require a basic understanding. Let's look at the next problem. So now we look at the eighth problem, which is a very interesting one. So we have given the values of x, y, and z as these, as you can see there. Log BCD by 2 base 2a log ACD by 3 base 3b and log ABD by 4 base 4c and W, which is log ABC by 5 base 5d. Now we need to find the value of n, and we are given this expression which is true for this. So let's start with this. Now we'll first find the values of x plus 1, y plus 1, and so on. So here we have x as log BCD by 2 base 2a. Now we'll add 1 to it. So x plus 1 is log BCD by 2 base 2a plus, no, we can write 1 as log 2a base 2a, so as we can make these bases the same. Now using the property of logs, x plus 1 is log BCD by 2 multiplied by 2a base 2a. 2 cancels out, so x plus 1 is log ABCD base 2a. So now similarly we'll find the value of y plus 1. Y plus 1 is log ACD by 3 base 3b. Now if we add 1, we can take 1 as log ACD by 3 base 3b plus log 3b base 3b. So y plus 1 is log ACD by 3 multiplied by 3b base 3b. 3 cancels out, so it is again, so it is, just a minute, yeah, so it's similar to y plus 1 is log ABCD base 3b, right? So similarly, now we can assume, we can just visualize that in all the values we have the same value for our log. So it is ABCD, ABCD. Now in Z plus 1 and W plus 1, we have 4 on both the places, yeah? 4C and 4. So if we'll add 1 on both the sides, it will just be log ABCD base 4C. So using these method, by, you know, checking how will other values be like, we can make our work very short and easier. So we can write Z plus 1 as, so we are given Z as log ABD by 4 base 4C. So log ABD by 4 base 4C. So it will again be Z plus 1 be log ABCD base 4C. W plus 1 will be log ABCD base 5D, right? Since we are given W as this, we can check it. Now we have all the values of x plus 1, y plus 1, z plus 1, w plus 1. Now we are given that reciprocals of these is equal to this log n base abcd plus 1. So now to bring in this value, we have to write inverse, or sorry, reciprocal. So we need to write 1 by x plus 1 as a single value. Okay, so for that we can write 1 by log abcd base 2a plus 1 by log abcd base 3b plus 1 by log abcd base 4c plus 1 by log abcd base 5d. Now using the base changing theorem, we can write log 2a base abcd plus log 3b base abcd plus log 4c base abcd plus log 5d base abcd. Now using the property of logs, we can write log 2a multiplied by 3b multiplied by 4c multiplied by 5d whole base abcd. Now it is log 326, 24 and 120. So log 120 abcd base abcd. Now we can write 120 into abcd. Yes. So now log abcd base abcd plus log 120 base ABCD. Now this is just 1 plus log 120 base ABCD. We can simplify it further, and now we got this in the form of what we were given initially in this question, log n base ABCD. So we can say that n is 120 as we got it here after simplifying. Yes, so this was a very interesting and easy question, which seemed to be a bit lengthy at first, but very easy. You, it could be solved very, very like quickly if you do it with basic understanding of logs. Rest, it was a nice question though. Now, so let's look at the ninth problem, which came in JEE Advanced. So for this, we are given let x naught and y naught be the solution of the following equations. So let's write these equations. So the first one is 2x to the power ln 2 is 3y to the power ln 3. This is our first equation. And our second equation is 3 to the power ln x is 2 to the power ln y. Now we need to find the what x naught is. So for this, let's take ln on both the sides for the first equation and second equation as well. So ln 2x to the power ln 2 is ln 3y to the power ln 3. So we can write this as ln 2 into ln 2x, which is equals to ln 3 into ln 3y, right? So we solve this. Now for the second equation, we can simplify it. Yeah. So ln 3 to the power ln x is ln 2 to the power ln y. Now ln x into ln 3 is equals to ln y into ln 2. So let's go further in this question. Now from this, what we can see is that we have the value of ln 3 and ln 2 is common in the both of the paths. Yeah. So what we can do further is that we can take the value of this, yeah, ln y, so that we can break this down into ln 3 plus ln y and put it in. We could also take the value of ln x. That would also be okay, but both are possible. But we let's go with ln y in this. So ln y is ln x into ln 3 by ln 2. So now we'll put this value in the first equation. Okay, so ln 2 into ln 2 plus ln x. Let's break this down, which is equals to ln 3 into ln 3 plus ln y. Now ln 2 whole square plus ln 2 into ln x is equals to ln 3 whole square plus ln 3 ln y. Okay, so let's take this value here. Now ln 2 into ln x minus ln 3 into ln y is ln 3 whole square minus ln 2 whole square. Okay, now ln y, we know from this that it is yeah, ln 3 into ln x into ln 3 divided by ln 2, which is equals to ln 3 whole square minus ln 2 whole square. Now let's write this as ln 2 whole square into ln x minus ln 3 whole square into ln x. Yeah, we can write this. Okay, so we just multiplied ln 3 ln 3 ln 3 whole square ln 2 here ln 2 whole square into ln x whole divided by ln 2, which is equals to ln 3 whole square minus ln 2 whole square. Now we can take ln x as the common in this, so it just becomes ln 3 whole square minus ln 2 whole square divided by ln 2 as this. Now this expression, and this expression cancels out. So ln x is 0, and so ln x can be written as, suppose ln x is 0, so ln x can be written as, suppose what we can write this as is maybe ln 1, ln 1, yeah, because e to the power 0 is 1, yeah, so x will be 1. That means there is only one possible value of x, which is 1. So here x not can be 1. So 1 is the correct answer in this case after solving the entire problem, where we get ln x is 0, and it is only possible when it is ln 1, right? So x becomes 1. So that's how we solved this question. It was a bit complicated, but yeah, it was nice. Okay, now let's proceed towards the 10th problem of J. Now this is the next problem, which seems to be an AP problem merged with the logarithms. So we know the basic AP that will be applied in this, yeah. So the sum of the first 20 terms of the series 460. So this is a pretty easy series. Now, if you remember, I told you a derived property from the laws, that log a to the power n power k is log a to the power n divided by k. If you remember this, this is one of the derived properties. Okay, so in this we'll use this property primarily. So log x to the power 7 to the power 1 by 2. Can we write this as log x to the power 7 divided by half, which is just 2 into log x to the power 7? Alright, now similarly, log x to the power 7 to the power log x base 7 to the power 1 by 3 is log 3 log x to the power 7. That means the common difference is 1, right? D is 1. So we can take the log x base 7 as common for the sum, yeah, for the sum into 2 plus 3 plus 4 plus dash 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 till 20th term, and 20th term we know that it will be 21. That's very common thing and obvious, yeah. So and Sn is 460, right? So 460 is log x base 7 into, now sum of the series, if we are given the first term and the n term, is a plus a to the power n by 2 multiplied by n. This is the formula for that. So 2 plus 21 by 2 into 20. This is what we'll write. Now 460 is log x base 7 into 23 into 20 by 2, which is 230. So log x base 7 is 460 by 230. So this is log x base 7 as 20, yes, sorry, 2, yeah, 2, and 2 can be written as log 49 base 7, which is equals to log x base 7. So x is what? Just 49. Now what we need to find in this question? X. So yeah, x is 49. That's how we did this question. So yeah, this was just an AP question which had to be done through a common way, right? So this was the end of our today's problems. I hope you liked the video and understood all the 10 problems very nicely. And since all of them were JEE based, so you might have realized how easy logarithms come in JEE, right? So that's how we did all the problems, and if you have any queries, you can always mail me on the given mail ID in the description. And if you like this video, please share, comment, like, and subscribe the channel. Thank you so much.